of this new reality. We selected a product that's not that complicated because we didn't want to get lost in the complexity of the product while trying to show you the possibilities. But we also selected a product that you wouldn't think of as being smart and connected because it never has been before. It's a mountain bike. Could we please run the video here and introduce the mountain bike? So I'm joined on stage here by two of my colleagues. First, Mike Campbell.
Morning.
In the sports suit. Mike runs our CAD business. And then secondarily, the masked marauder here is Rick Bellotta. Rick was one of the founders of the ThingWorks business, and he's the head of product and technology strategy. And they have with them a mountain bike from Santa Cruz, who happens to be a PTC customer. Mike?
That's right, Jim. What we have here is the Santa Cruz V10 downhill racer. So this bike was the first all-carbon frame bike to win a World Cup back in 2010. Since then, they've won a variety of world championships with it, and we're very proud to have Santa Cruz as a customer of ours, and we thank them for the bike. This bike is completely designed and engineered in PTC's CAD software. So here you see in the 3D modeling environment, the model that was used as the digital prototype during the development of this bike. And they use that tool, they use PTC Creo, to get as much confidence in the design as they can before they go off and manufacture it.
All right, Mike, so when I'm looking at the CAD model in Creo and looking at the bike, they look a little different. I mean, this bike doesn't strike me as something that was designed to be smart and connected.
That's right. It wasn't designed to be smart connected, and that's the reality for many products out there in the market today. But we very easily instrumented it with a collection of sensors like the ones that I'm holding here. This harness, if you will, includes a battery pack and a Raspberry Pi for connectivity, and a handful of sensors that we're using to measure and monitor the key characteristics that will help us understand the performance. We have sensors that are measuring the wheel speed, for example, the cadence of the pedals, the compression on the different suspension mechanisms, as well as the steering angle measured by the angle of rotation on the handlebars.
Okay, so we've instrumented the bike with some sensors and a Raspberry Pi for Wi-Fi connectivity. And suddenly we have a bike that's in that yin and yang of being digital and physical at the same time. And we've entered with this bike into the new reality. And as Mike mentioned, now we can monitor what's going on with this bike. So as Rick interacts with the bike, if you look at the ThingWorks dashboard we created, you can see that we've given this bicycle a voice. Rick gave the back wheel a spin, and we're looking at the RPM gauge on the back wheel. We see a slip skid indicator because the back wheel's turning at a different RPM than the front wheel. So something's not quite right. We must be in a skid. So that's a pretty simple form of analytics. And you see a number of different readings on the suspension link angle, the acceleration, which at rest goes back to 1G, the force down on the frame. We can see the fork displacement, the speed of the bike, and so forth. So we have ourselves a very smart and connected bike. Okay, so this is a valuable idea. You know, dashboards like this have hundreds of applications that create all kinds of value for engineering, for operations, particularly for service, for sales, and so forth. Lots you can do with this basic connectivity concept. And what we're really seeing here is the ability to have real-time insight into the real-world performance of the bike. And we've been able not just to collect and display sensor readings, but to perform some basic analytics and display that as well into our dashboard. This area of analytics, I'm going to come to a little later, is really one of the hottest spaces in the IoT marketplace, because a lot of times the voice of the product needs some translation. Sensor readings by themselves don't always tell us the full story. We need to analyze what is the message encoded in those sensor readings that really tells us what's going on. So this dashboard gives us useful information, but it doesn't give us the whole picture. It's really just the tip of the iceberg. So I might ask, how could I understand what's happening to the physical bike if I'm not next to it, if I can't see it and compare the two? How would I know if it's really being ridden or not? I mean, I see readings, but that's a little hard to interpret. So we've got an answer for that this morning, a new idea, and it may surprise you to learn that one of the newest approaches in IoT actually goes back to our roots in CAD and PLM. Mike, why don't you tell us about it?
So the idea here is that by leveraging IoT, we're able to bridge we're able to provide you that physical proximity in the digital world. So what you see here on the screen is actually the concept of a digital twin. The digital twin is a representation of this particular physical bike. You can think of it as a product avatar for this bike. So as Rick moves the bike, here in reality, we see the digital twin updating in real time. Rick, why don't you get on the bike and give it a ride, and we'll see how it behaves. Now, this digital twin that you see here is showing us the behavior that Rick is exhibiting, but you're also seeing some basic analysis that's happening. So not only is it behaving realistically, but PTC Creo is recognizing the data from the sensors and then doing some basic analysis to provide us even deeper insight into the product's behavior. Contextualizing what's happening with the bike in this way is incredibly valuable. It gives us the ability to understand what's happening in the product when we can't be with it, when we can't be next to it because, for example, it's a space station, or when it's too big, a factory full of machines that might be giving us data, or too small, like nano machinery. This context is very, very valuable from an engineering perspective. It gives the designers and the engineers insight into the real-world usage of the product and allows them to do things like optimize its design based on how it's being used, or improve its quality based on how it's actually being used in the field, and also gives us deeper insight into the different aspects of value that our customers see in our products. So this is a level of enlightenment that IoT delivers back into the digital world. Now, so far we've looked at examples of where data is streaming from the physical world into the digital world, and that's valuable when I can't be with the product. But what if I can be with the product? In fact, what if I need to be with the product so that I can service it and repair it? Well, that's where the idea of augmented reality becomes part of PTC's vision for a new reality.
All right, so what you're going to see now is that Mike has picked up an iPad, which we've connected into the displays here, and is running an augmented reality application that we've developed. And he's able to link the augmented reality view through the serial number of the bicycle into that exact bicycle, and then he scans the AR tag just to get the 3D coordinate system of that bicycle, which will be pretty useful for augmentation. And now he's interacting with the bicycle. And if we could get that display up here. Can we get the iPad display on the screen?
Can you do it on my shoulder?
Yeah. Okay, yeah. Bring the camera up here and show. Can you show in the camera the iPad display, sir? Sorry, minor technical difficulty. Can you actually point at the iPad? Our iPad connection is not working after all, but we'll use this form. So you can see now in the camera that we're looking at the bicycle and projecting or augmenting onto that bicycle a dashboard. And we put a gauge on the back wheel for RPMs and a gauge on the front wheel. And we've added indications for slip, for the force vectors and the angle of the suspension and the angle of the steering, those 7 different sensors. And we're projecting those green arrows are, in fact, the red arrows, the reaction forces that were shown from the CAD model. So we're taking sensor readings, we're taking simple analytics around slip skid, and we're taking some pretty sophisticated engineering analytics from CAD, mashing them together and augmenting them onto the bicycle. So, all right, good enough, guys. Thanks for that. Appreciate it.